All right, so in the previous video, I tried to run a model. This is the model I tried to run, and I ran into problems. Because basically I got this error. I think I figured how to fix it. So what I did, um, what I did this. What I did, let's create a new row. Well, a new row to actually deal with the regression and enter the input and so forth. So let's click here and see cell below. So I want to visualize data. I will type TF, click run. All right, so this shows me what data I work with. So I have this numbers here. This is number rows. This is the date, WTI returns, Henry Hub, LNG. So I want to run a regression. I want to specify my X variable. I want my X variable to have these three variables. I want it to have returns. My X variables, my exogenous variables. I want it to have returns, Henry Hub, and LNG. I want to have three exogenous variables. So what I'll do, this is the code I'll type in here. So I have x variable 2, drop date. This will drop the date. And axis 1, this will drop the column. Then I'll do the same thing to drop this. So basically what I do when I enter the two codes one time, because I ain't running on the slide my line. If I want to drop returns, in fact, I'll drop returns. I'll actually do that. I'll type in x var 02 equal. See, I don't really like to type out all this code, so I just want to copy and paste. Okay, paste. The drop x var 2 underscore. So basically what I'm doing is that I have to put here, I put x var 2 because I now work with this here. And I want to drop returns. RETURNS and click run. So let's visualize this variable, x variable 2. VER. All right, so this is now a vector, not really a vector, but it's really a matrix. As a matrix, I have two variables, Henry Hub and LNG. So now I want to run back the regression. I want to run a regression with the dependent variable being WTI oil prices, and the two explanatory variables will be Henry Hub prices and LNG prices. Let's see. Type this here. I've written back the same model here because the first one up here did not work. Well, actually, if I run this model, it will override this model here. I'll do that because I don't really want this model in your ticket, so that's kind of useless. WTI is a dependent variable. The independent variables. And Click run. Let's see it. Haha, it worked. Problem, perfect arrow squared. Why perfect arrow squared? That's because Henry Hub is the problem. Remember, there was Henry Hub is really WTI divided by 6. So because of that now, we have a perfect arrow squared is a perfect fit. You see the coefficient? 6, because Henry Hub is really 1/6 of WTI. So yeah, the probability of the test statistic is statistically equal to 0. That's for Henry Hub. So this says it's significant. LNG now, LNG is insignificant. So, I mean, if this variable's insignificance shows that LNG has no effect upon WTI prices. Of course, we know this is just a bogus regression. We just threw some data there and we just run this regression there. We didn't actually get proper LNG prices. We didn't actually get proper Henry Hub prices. I just divide WTI prices by 6 to get Henry Hub. I just perform a transformation earlier on to get LNG. Let's see where I get LNG. This was the transformation. This was LNG here. So I'll create LNG. So the regression is running. This is all this is just a perfect fit. This is a terrible model. This model has overfitting. But it must have overfitting because you have two time series that are perfectly correlated. There's some kind of multipolarity. There's a perfect relation between Henry Hub prices and WTI prices. So I mean, that can't work, plain and simple. So this is how to run a regression here. So let's say we want to run a regression with 4 variables. Let's say we want to work with returns. If you look at this x variable 2, x variable 2 had only Henry Hub and LNG. X variable underscore 02. But this variable, x variable underscore 2, would have returns in it. To verify, we just click add and type in x bar 2 run. See it have returns. So then you want to take this variable, I will re-specify the regression. Let's delete that. Linear model tree. Print linear model tree summary. Now, why did I change this? Because if I check, this is one regression here, right? This is linear model regression 2. If I didn't change this new code will overwrite everything what I did right here. And that's what I do not want to do. So I change this. So this is now a new regression. And since this is a new regression here, I need to go back here and change this because this will print the summary of what we just did here. Remember before when you see the command print shows whatever, it shows the output whatever I just presented. Well, we apply it right here. All right, so this has 3 variables, returns, Henry Hub, and LNG. The coefficient for the returns is statistically insignificant. How we know that? It is greater than the probability value of 0.01. So that means we cannot reject the null hypothesis that this beta coefficient here is statistically insignificant from 0 at the 10%, the 5%, and 1% level of significance. But these two coefficients, the one for Henry Hub and the one for LNG, are statistically significant. How you can see that? Is the probability of the test statistic here is less, well, this is come like a 0%, 0.000. It is less than the 10%, 5%, and 1% level of significance. So we can reject the null hypothesis in terms of the the statistical significant test for the beta coefficient, we could reject the null hypothesis that the beta coefficient is statistically insignificant, meaning statistically it is equal to 0. Yeah, we have a perfect R squared. So this is the problem, and this is because of Henry Hub, and so forth. This was just a short video to run the regression. I will end the video here, and in the next video, I'll proceed and I'll go forward.